All right, we've already had some questions. Are there, now I'm recording. Any questions? Or other questions?
The master set.
Yes.
When is it due? Cause I think I had wrote down the first and next Friday, so I just wanna make sure.
Master set 14 on the 5th.
Yeah, okay.
And then there's a quiz on chapter 14 on Thursday, the
I think
31st.
that's the only thing that I have wrote. Thank you.
I need to update my physical calendar so that I remember that stuff. That's supposed to coming in here.
The amount of times I've rewritten this lab was like 5 times. Cause I couldn't figure out, what to do on mouse speed.
That's one of the reasons why labs have as much weight as they do. Because there was a student who fairly said he spent so much more time on the labs than some of the other stuff that it seemed unfair that labs counted as little as they did, so I upped it.
And the lab is due tomorrow, correct? Cause for some reason I had that it was due the 23rd and I know better than that.
I don't, let's see, the Hooke's Law lab was due, yeah, and so,
Everything we measure correctly.
The day
Today
is 29th.
29.
okay, so we are here. Sure. I don't remember when we actually did that. It's due a week after we did it. So did we do it last
Yeah, we did it last,
Wednesday? Okay.
Okay, so that was when we actually did it, was the 23rd.
So that's the simple SHM lab.
I just knew the 23rd was not right.
But the, what was it, table E, or, sorry, table D was what I had the most trouble with because the slope, like almost doubled from the, from table A, but I knew that wasn't right, well, I knew that wasn't the spring constant because it didn't make any sense, because if the coil was longer, it'd be easier to pull down.
Yeah, so the slope should have been, oh,
So the slope was bigger, but the actual spring constant is smaller.
yeah, the spring constant is smaller. You would expect if you, because I think I say roughly double it,
Yeah.
double
yeah,
height,
yeah,
so
double.
the slope actually should have doubled, which would have given you half the spring constant.
Mhm. And, I couldn't figure that out because I was like, well, I know that's not right, cause I was confused, because last lab, the slope was the spring constant. And I was like, well, wasn't last week's slope the spring constant? So I was like, how's that working?
Yeah, last week's lab, it shouldn't have been the spring constant.
It wasn't?
It should have been the reciprocal of the spring constant.
Oh,
There are a
yeah.
number of people who,
Yeah, that's what I was
okay,
wondering.
okay. There are some people, I can't remember who did it, but there are some people who plotted it backwards.
Yeah, right, the
Split
force is,
with-
yeah, the force is the X, yeah, but, yeah, I was just confused about that,
And Nick, you popped your hand up?
Not a stretch.
Okay.
The
Selena?
lab for tomorrow, do you have it posted yet? It wouldn't let me on, I don't know if it was, what the deal was.
I will address that in a moment.
Okay.
I have
Sorry.
not forgotten. Nope, not a problem. Other questions not concerning the next lab? So plot period versus square root of mass. That was one of the ones you actually just, right, okay. All right, so if this is a line in the procedure, we're gonna say line 15, procedure step 15. I think at this point, it was not an issue, everybody had the graphs in the lab, the first lab, which I will be handing back today. So the fact that you have to do a graph is already caught by this group. What is the title of this graph?
Area versus square root mass.
Yep, that right there, that's the title. Now, I would recommend don't do variations of it, but occasionally somebody does that are acceptable, and more often than not, someone takes liberties and it does it wrong. But, so there's your title. So you've got your graph, and it says period, versus square root of mass, preferably not drawn this badly. Okay. Now, what's the vertical axis gonna be?
Period.
Period.
So that leaves this one to be square root of mass. As far as what's written there, what's missing?
There's markers, like your, not variables, like your number.
You mean the
number
data
of-
points?
Yeah,
Yeah, okay, eventually, yeah, I will get to that.
the origin.
I will assume that the origin is where they intersect, but not necessarily. The origin does not necessarily have to be there.
Oh, I have a question about you said you wanted the 5 graphs.
Yep.
I just titled because they're plotting the same thing.
Right?
I just plotted them, or titled them, experimental period versus square root of hanging mass E.
That works for me. That's an example right there of doing a little variation that works.
Okay.
The legend.
If I'm only doing one plot, a legend's not necessary, but if I'm doing 3, like in the first lab, yes, a legend is necessary. And just be careful if you're printing in black and white.
The units.
Exactly. So there'd be a space followed by units
Parentheses.
in parentheses. And I assume this would be square root of kilograms.
Oh, whenever I made my graph, I just put kilograms because it was after I'd already square rooted them. So if you squared them, you just get that.
So you plotted, what again? You
Okay,
plotted,
so like if you put in the hanging mass, the square root of the hanging mass, and you actually solved it, that's my plot points. Like I don't know how to describe it. Like if you squared this, you get my original hanging mass, the actual.
Okay,
This
right.
is after it's already been squared.
right,
Yeah, square root. yeah.
yes, okay, yeah.
So it's just kilograms, because you don't square root it again.
No, but the units, I'm not square rooting, that should be square root.
Yeah, I know, but like, if I wouldn't put these numbers under the square root again, because I already did. So it's just kilograms.
No, it would not be. All right, so if I have a mass so if my mass in kilograms is 4, and my period in seconds was 3, then my data point would be, so I got 3 here, that's my
3
period.
seconds.
And then that would be 2. Oops, sorry, data point would be up here, 2. And that's the square root of the mass. That 2 comes from taking the square root of this 4 kilograms.
Oh, yeah, that's what I did.
So my units here would be square root of kilograms. Because I'm taking the square root of 4 kilograms. Square root of 4 is 2, square root of kilograms is square root of kilograms.
Yeah, that's what I did.
Okay. So,
Yeah.
what I was hearing you said is that you just wrote kilograms here.
I did write just kilograms there, but I thought that was like the original hanging mass, the effective,
That should be square root of.
yeah, the square root of effective hanging mass.
Right?
So you just put down the hanging mass, because you'd have to square root them.
The plot should be against the square root,
Right.
which I feel like we're not on the same page a little bit.
Take a look at my graphic. If I squared this, I would get the original hanging mass.
Right. So these numbers down here
Yeah.
reflect those numbers right
Yeah.
there. So you've taken the effective mass, you've taken the square root, you get those numbers.
Mhm.
Okay, so the units of these numbers right here is the square root of kilograms. It's not kilograms, because you've taken the square root of it.
Okay,
So your kilogram should have
okay,
somehow some indication of a square root.
alright. Yeah.
I wasn't sure whether it almost comes across like, yeah, whatever you're saying, I'm gonna go with it, but it didn't sound like you were buying into it.
Well, no, what I was confused about was, you told us not to put the units, because if the units are already on there, because it, say, like,
Oh.
you put meters,
Right,
and then put meters again, it's meters squared.
correct.
Well, to me, that sounds like you're squaring the square.
Except, in this particular case, there's nothing written after the 2. So the units are whatever I have in parentheses there,
But it'll be 2
square root of kilograms.
already, yeah, but it's actually 4 square root of kilograms.
No, it was 4 kilograms.
But you put the 4 in the square root.
I put the 4 and the units under the square root.
Right. But if you put the 2 in under the square root of kilograms, then,
No, all right, so when you're doing a plot like this, let's get rid of stuff. All right, so if this is, just say, time squared, it is a second squared. And that should be capitalized there. So for example, if I have a graph and I have one axis labeled time squared with the units of s squared, what I'm saying is that this number right here, that represents time squared equals 2 seconds squared. Whatever's in parentheses goes after the number. So if I square the time, I'm gonna get 2 seconds squared. In this example right here, where I've got the 4, I have a 2 right here, so this represents the square root of the mass is equal to 2 square root of kilograms. Whatever's in parentheses is assumed to be after the number. If I square both sides, I get mass is equal to 4 kilograms. That was my original data point right there, but I took the square root of both sides in order to be able to plot it onto this graph.
oh, you multiply, oh. Okay, yeah. I see now.
Okay.
Mhm.
All right. Back over on my plot over there, I'm now gonna do a graph. So what do I choose as my type of graph to pick?
Scatter.
Yep. So scatter plot, it'll ask what the data is, or it'll make some assumption, but eventually you clean it up and you get data points that are popped in here. And first, all you have are data points. Then what?
Then you go put the time line in there. I forgot what it's called.
We're gonna put the function line.
Here,
Okay.
Just gotta choose it from the layout.
layout.
Sometimes referred to as trend line.
There you go, that's the word.
You are not to pick the thing that's connecting the dots already. So you pick a trend line. So add trend line. On the software that I used, it's a right click and it says add trend line. Actually, it has trend line as 2 words. Using Excel, it has trend line as 1 word. It will go through and automatically there's another pop-up, and then you check 2 boxes.
You're gonna put, root square and, the slope.
Show equation.
Yeah.
So it's gonna give you the line, it'll give you y equals or f of x equals or something like that, or if it's, I guess Google Sheets will just give you
Why?
the right-hand side of the equation, which actually makes it an expression and not an equation. The Excel will give you y equals something x plus something, with r squared equal to some number. And OpenOffice and LibreOffice will give you f of x instead of y. And so then it'll populate it. I saw some variation in the graphs that were displayed. More variation than I was expecting. So, anyway, that's a repeat of some of the stuff in the graph orientation video.
One last question for you.
Sure.
So on, like, on A and D, where we take the average of the two positions where the coil's leaned over.
Right.
Do we need to round that to 3 decimal places, or should we leave it at 4 if it falls right in the middle of it? Like I got some, it's like 0.6375.
Either way,
Okay.
if we were doing significant figures, it would be to whatever, however far the numbers you were averaging went to.
Okay.
But personally, don't really care for significant figures, or at least having to deal with them. But if you like them, go for it.
No.
Okay. Other questions? Let's see, jump out. Oh, when doing the analysis, please make sure you're actually answering the question. Which might seem obvious, but there are a number of times I wrote Y, Z. You didn't answer the question. Sometimes there's an extra letter in there, like, you didn't really answer the question. But, which means you maybe did, but I'm not sure.
When will we be getting the last week's lab back?
The Hooke's Law Lab, you'll be getting it back today.
Okay.
And this was not a huge issue, but if I say based on the slopes, or based on the slope, what is such and such? I do expect the slope to be showing up in your work there. And then does the graph support, or in the Hooke's Law Lab, based on the graphs, do the springs obey Hooke's Law? And there's a common thing that I saw in some of these. I mean, it's a small sample here, but in larger context, I see other groups do it too, where they talk about the slope of the line was constant. Well, yes, because when you said add the trend line, you said make it linear, make it a line. And lines by definition have a constant slope. So if you're looking at, does something obey an equation or a formula? For Hooke's Law, we had that, I guess, jumping to the chase, we had, I guess we already plotted weight. So it was weight versus is equal to K delta X, ignoring direction. And we plotted the displacement versus the force. So I want to get this into slope-intercept form. In math class, slope-intercept form would be y equals slope x plus b, where y refers to the vertical or the dependent variable, and x refers to the independent variable. So since my y value is displacement here on my vertical axis, I need to solve for displacement. So delta x is equal to w over k. To get it more explicitly in this form here, I have delta x is equal to 1 over k weight plus 0. At this point, it should line up directly. My vertical value is displacement. My slope is 1 over k. My horizontal is weight, or the force in this particular case, and my intercept is 0. I expect there to be a linear relationship, and so that's why I say plot a line. So, in order to see if it really is a linear relationship, there's two things I need to be able to figure out. One of them is the r² value. How well do the points actually fit on the line? Now for the rubber band, the points looked like that, but the line looked like that. And it was a relatively high r² value because we aren't dealing with a whole lot of points. But I think if you look at those data points and you said, what kind of relationship do you think that is? Do you think that's plotting out a straight line? I don't think most people would say, yeah, that's a straight line. So just be careful about that. So how well do the points actually fit? How close does this actually get to 1? If r² is equal to 1, it's a perfect fit. Now, occasionally, let's say it's 0.993, and a student just goes ahead and rounds off to the nearest tenths place, in which case you get 1. There's a huge difference between this and this. This says perfection. Or it says, I decided to round off to make it look good. This says that it's not a perfect fit, which is more realistic. I see r² equal to 1, I get suspicious. Yeah, you should be able to take it out to 4 decimal places at least.